Welcome to the notes on the number of solutions when you solve for x. So we're going to talk about what we're actually doing when we're solving for x. So when we look at 3x minus 5 equals 10, when we're solving for x, so what we're doing is we're trying to find the number that when we plug it back in to where that x is, it will make both sides be equal. It'll make this equation true. So if I solve for x the way we've been doing it, we draw a line where the wall is, or where the equal sign is, to make our wall. With x we have a times 3 and a minus 5. First we get rid of the thing we're adding or subtracting. To get rid of a negative 5, we add it away. If I do that to the left, I have to do it to the right, because our goal is to keep both sides equal, so we know what makes it equal. So I still have these three x's. Minus 5 plus 5 is 0. They cancel, eliminate, go away. They're not there. We don't write them. It equals 15 plus 5, or 10 plus 5, which is 15. Now this is 3x, which is 3 times x, equals 15. So to undo multiplication, we divide it away. On both sides, 3 divided by 3 is 1. X is still there. Equals 15 divided by 3. Which is 5. So if I were to check that, 3 times 5 is 15, minus 5 is 10. And our goal was it for equal 10 to equal 10, and does 10 equal 10? Yes, it does. So we were right. There was one answer, only one number in the entire world, which is x equals 5, that when I put 5 in there, the two sides are equal. Well, sometimes there isn't just one solution. Sometimes there's no solution. For example, a no solution happens when there is no number that will make both sides equal. So here it says x equals x plus 1. Well, if x is 10, then this equation is 10 equals 10 plus 1, which is 10 equals 11. Does 10 equal 11? No, that's not true. Not true. I don't want to put an X. What do I want to put? I'll just put not true. Not true. Right? Is there a different number that would make it true? If X was 1,000, but then on the other side I take 1,000 and I add 1, it's going to be 1,001. The right side will always be one more than the left because they're the same. It's an X and it's an X. But on this side, you don't add anything to it, and on the right side, you're adding 1 to it. There's never going to be an answer, an x, that makes the two halves true. So mathematically, what does this look like? Well, if I look at this equation down here, it says 3x, and here's another 3x. So both times, whatever x is, I'm timesing it by 3. But then on the left, I'm going to minus 4. It's going to go down 4. And on the right, it's going to go up 8. They will never be equal. So right now, if you look at it and say, look, they're both being times by 3, but then you're going down 4 and up 8, they'll never be equal. You could tell me there's no solutions to this. But let's say you don't see that. So you start to work it out, and you say, well, first I add my 4, so I get 3x equals 3x, x, plus 12. Maybe here's when you realize it. Look, they're both 3x, but on this side I'm adding 12, and this side I'm not. They'll never be equal. So you could tell me here there's no solution. But if you don't see it, you can still keep going and say, okay, I'm going to minus these 3x's over, but 3x minus 3x is 0. Equals 3x minus 3x is 0, plus 12 is 12. 0 does not equal 12. No. There is no solution, because this is not true. 0 does not equal 12. So when we solve for x, sometimes there can be one answer that will make the two sides the same. Sometimes there isn't anything that will make the two sides the same. But sometimes everything will make them the same because they are the exact same. So for example, infinite means all. Infinite means how forever and ever and ever, to infinity and beyond. Like it goes on forever, every single number would work. So you could write infinite solutions or all solutions. But this happens when the two halves, when the left is the exact same as the right. Like right here, x is equal to x, they're the same equation on both sides. So no matter what number I plug in, if x is 10, then it says 10 equals 10. Does 10 equal 10? Yes. 10 makes this true. But what if I plugged in 5? Well, it'd say 5 equals 5, and that makes this true. And if I plugged in 17, it would say 17 equals 17, and that makes this true. No matter what I plug in for x, this is always going to be true, which means that it has infinite solutions, or all answers. So you recognize this by recognizing the two halves are the exact same. So I draw my line, and step 1 is to do parentheses. There's no parentheses. Step 2 is to combine like terms, and there are like terms. On the left I have a -2 and a +9, and that's two number terms that I can put together. So first I still have my 8x's, but -2 + 9 is +7. And look on the right, it's also 8x + 7. So when I plug in an x, both times it's going to be multiplied by 8 and then being added 7. They're going to always be the same because the two equations are the exact same on both the left and the right. However, if you don't see this, you can start to solve for x by minusing the 7 away, minus it away. And so then I'm just left with 8x, 7 minus 7, 0, equals 8x, 7 minus 7, 0, that's not an x, let me fix that. Harder and harder the further down I write. X, alright. And then it says +7 minus 7, well that's 0. Well now, it says 8x equals 8x, I'm like, oh look, they're the exact same. You could tell me here that it's all solutions, or infinite solutions. But if you want to keep going, you would subtract the 8x away, 8x minus 8x. 8x minus 8x is, I'm going to move over here so you can see, equals 0. And then on the left or right side, equals 8x minus 8x is also 0. And does 0 equal 0? Yes, it does, which is our clue, our hint, that means the answer is all solutions. You could also write infinite solutions. But anytime you end up, when you're all done with 0 equals 0, it means it's infinite solutions. But if you end up with something like 0 equals 12, well, that's not true. So then there's no solution. But if you end up with just a number, then there's one solution.